at Joggins. Look what the sea uncovered. In Nova Scotia, on the shores of Chignecto Bay, near the head of the Bay of Fundy, lies the village of Joggins. Like many communities in Nova Scotia, this one first made a living by mining coal. As early as 1720, coal was exported from there to Boston. At its peak, the mine yielded about 91,000 tons of coal per year. The Joggins mine finally closed in the late 1950s, but in recent years, interest in this area has continued greater than ever. The 150-foot high cliff on the shore of the bay reveals layers of sandstone, mudstone and fossilized plants. These have a story to tell. Just steps ahead of the incoming tide, with average range of 34 feet, Bob Banks descended to the beach at Joggins to photograph this cliff. In the cliff near Joggins, the rock layers strata are tilted at an angle of about 20 degrees. This means that the layers, which were deposited first, are partly slipped sideways to the north, out from under the higher lying layers. It's like tipping over a pile of dollar bills. In the lower cove up to Joggins village, about 4,600 ft, 1,400 m of rock layers are exposed along 3.6 mi 6 km of coast. These beds are part of a larger collection of tilted rock layers, which continue for 30 mi 50 km, and, geologists calculate, represent about 14,500 ft, 4,400 m of vertical rock if we could stack all the layers back on top of one another. M.R. Gibling. 1987, a classic Carboniferous section, Joggins, N.S. Gill, Society America Centennial Field Guide, any section, 588, 409-414 CP 409. According to standard evolutionary interpretations, the rocks at Joggins represent fossilized remains of a succession of river channels and floodplains that occupied this area over a period of 10 million years up to 300 million years ago. Lane Ferguson, 1988, The Fossil Cliffs of Joggins. Nova Scotia Museum, Halifax pp 52 cp 31. Near the top of the cliff are 6 to 7 m of flat-laying clay. These flat layers are said to have been laid down during the Ice Age, about 13,000 years ago. There are no rocks representing any time interval between 300 million years and the recent past. This is quite a gap. On the basis of theoretical criteria ideas only, geologists suggest that the Joggins rocks are very old. This is not how most people understand the geological column. They think it is an actual stack of rocks. The most dramatic features of this cliff are the preserved trunks of club moss trees. These extinct and exotic-looking plants probably grew up to 150 ft high, 55 m. Many achieved a diameter of about 4-6 ft, 1-2 m at the base of the trunk. Relatives of these club moss trees do occur today, but they are tiny, seldom more than 25 cm, 10 inches tall with stems less than 1 cm in diameter. The modern genus Lycopodium is widely distributed on the woodland floor of temperate climates. They are common even in northern Ontario, but few can be found in Alberta. Like ferns, these plants reproduce by non-sexual spores. Only about 6 inches tall on right, this modern Lycopodium seems a far cry from the massive tree trunk left entombed in sandstone and coal at Joggins. In the Joggins cliff, most of the club moss tree stumps are preserved in growth position. The stumps are upright with roots penetrating into the lower sediments, now rock. One extreme case was recorded in which root up to 4 in or 10 cm in diameter extended for 16 ft 5 m away from a tree trunk. Some stumps are as short as 3-5 ft 1-1.5 m while others are several meters high. Once a trunk as tall as 25 ft 7.6 m high was found. These stumps are unusual among fossils in that they penetrate vertically through a considerable number of rock layers. The term for such a fossil is polystrate. The stumps themselves consist of a cylinder of coal, about 1 cm thick, which represents the bark. The interior is filled in with sediments, which have turned to sandstone and mudstone. Gibling P413. Apparently the interiors of the trunks have rotted away, so that sinking sediments were readily able to fill the cores. The trunks are generally embedded in sheet sandstone, widespread layers of sand, which hardened into rock after blanketing the area. The roots of the stumps generally sit in mudstone or on a layer of coal. Gibling P413. The interesting feature about polystratic fossils is the time factor. These hollow stumps could not be expected to have remained intact for hundreds or thousands of years while the various sedimentary layers accumulated around them. The whole process had to be rapid, and indeed that is what the Nova Scotia Museum booklet says. The hollow trees formed ideal traps, which were then rapidly filled by sediment. P14. Further down the page the booklet terms it very rapid burial. Concerning a thick stand of horsetail relatives, also plants, preserved at the base of the cliff, the booklet says such fossilization could only have happened as a result of very rapid burial, such as one would expect when a river burst its banks. P24. The conclusion which geologists have drawn is that the trees at Joggins were drowned by sediments dropped from fast-moving water currents. Since the stumps are found, generally in growth position, at a variety of levels in the cliff, it seems reasonable to many to interpret the evidence in terms of a succession of forests which grew and were preserved, one on top of the other. Geologists conclude that as many as 40 different forests were engulfed by flood-borne sediments. Because there is very little peat organic matter associated with these rock layers, geologists conclude that each forest survived only about 100 years before catastrophe struck. Museum Booklet P34. The standard scenario for these sediments then is catastrophic burial of one club moss forest after another. In between there was a more leisurely process of depositing sedimentary rock layers. In all, millions of years are imagined to have passed. It will come as no surprise that there is another way to interpret the rocks near Joggins. Recent work by coal geologist Dr. Stephen Austin suggests that the long age scenario may not be correct. The sediments, with their trapped plant material, could have accumulated within a few months. Dr. Austin developed his floating mat model from his studies on coal beds in Kentucky. He proposed that trees, stripped from land by a catastrophe, would at first collect in a floating log jam or mat. Later these trees would sink, mainly in a vertical position with root end down because that end is heavier. Such logs would be found at various levels in the sediments depending on how quickly they sank. Notice the numerous rock layers which entomb this club moss stump. Notice too, the texture of the trunk. Evidence that tree trunks sink in a vertical position can be found in the work of W. J. Fritz, who studied the famous multiple fossil forests of Yellowstone National Park geology. 1980 Vol 8 pp 309-313. The traditional interpretation of this region is that forests were preserved on top of other forests with the whole process consuming millions of years. But Fritz concludes that no such forests ever existed. Rather, the tree stumps were carried by mud flows to their final resting place. Many of the petrified vertical stumps in the Lama River Formation have a wide root system with short, broken trunks. Such trees would behave as an irregular clast with the vertical position being most stable and would tend to be deposited right side up. Fritz P. 312. Confirmation of this interpretation came in the aftermath of the 1980 Mount St. Helens eruption. An actual log mat developed on Spirit Lake when landslide-generated waves stripped the forest from surrounding slopes. Dr. Austin documented that trees do sink vertically. Within 5 years, he estimates that there were about 19,000 upright stumps on the floor of the lake. Sonar records and follow-up scuba dives verified that many of the upright deposited trees have root masses radiating away from the bases of the trunks. Notes from Dr. Austin, July 1988. The roots of some of the trees were already buried by up to 3 ft of sediment, while others still sat on the lake floor. This is the kind of phenomenon which might later be interpreted as multiple forests, growing one on top of the other. As to Joggins, the fact that the club moss roots often sit in mudstone has been cited as proof that these trees were buried where they grew. The mudstone, however, is also found inside the stump cores, as well as in frequent interrupting layers within sheet sandstone Gibbling P411 and also within coal layers P412. This is consistent with muddy sediments sinking onto submerged artifacts. The mudstones are said to contain abundant roots, but often difficult to identify, Gibbling P412, but so do the sandstones, P411, in which the club mosses are not supposed to have grown. Sometimes the stumps sit on top of a coal layer, P413. Initially these roots might have been far from the soil lying under the coal. According to Gibbling P412, a 12 in 30 cm thick coal bed represents about 10 feet 3 m of original peat. Channel sandstones are supposed to indicate that flooding rivers were the source of the sediments. However, the channel sandstones are relatively uncommon at the lower levels near Joggins, where so many fossilized trees are found, Gibbling P411. It is only at higher strata that such infilled channels become common. The cliffs at Joggins are so constantly eroded by the sea that few stumps are visible for more than 3 or 4 years. But year after year, as some fossils disintegrate, others are exposed. These polystratic fossils tell a consistent story of catastrophic burial by sediments carried in water. Let us not be too hasty to insert millions of years into the equation. Margaret Helder, October 1992.